Setting up AI on your own computer can feel, well, super intimidating, right? Every tutorial out there seems to scream about needing these crazy expensive GPUs and some kind of supercomputer setup. Well, today we're going to blow that idea right out of the water.
So many of us think that. Yeah, you absolutely do. But what if I told you that you could build a complete, totally private, and seriously powerful AI coding assistant right on your normal, everyday computer without spending a dime?
Because that's exactly what we're about to do. We're going to use the amazing LM Studio to run open source models right here on this machine. Then we'll hook it straight into VS Code with a fantastic free extension called Continue. We are literally going from zero to a fully operational offline AI assistant.
And just to prove this isn't some trick for a secret high-end machine, here's the exact home office setup I am working with. I've got 32 gigs of RAM, but honestly 16 is totally fine if you just stick to the smaller models. A standard Intel CPU, and here's the really important part, integrated graphics. That's it. No fancy, dedicated GPU at all. And by the end of this exact machine is going to be churning out code without sending a single byte of your data to the cloud. Okay, first things first, we need to set up our local AI hub. And for that, we are using a tool called LM Studio. Honestly, it's perfect for this because it's super beginner-friendly. It gives you this great visual interface to manage everything, which is way better than messing with command line tools when you're just starting out. Getting it running is a piece of cake. Just download the installer for your OS. Now, when you first launch it, it's going to ask you to download a model right away. Just skip that for now. We'll handle it in a sec. The one really important thing you have to do is dig into the advanced settings and flip the switch for developer mode. This unlocks the local server that we're going to need later. Once you're in, you'll see there are really three main spots we care about. First, the Discover tab. Think of it like an app store, but for open source AI models. You can download them with just one click. Then there's the Chat tab. Pretty self-explanatory, right? It's where you can talk to your AI. And finally, the Developer tab. That's the magic button that'll run our local server so VS Code can talk to our AI. Okay, LM Studio is all set up. Now let's talk about picking out the AI's brain. And I'm not kidding, this part is absolutely critical. If you grab a model that's too big or just the wrong type, your poor machine is just going to grind to a halt. So let's do a quick breakdown of what you actually need to look for. All right, first up, parameters. The easiest way to think about these, they're basically the brain cells of the AI. And yeah, more brain cells usually means it's smarter, but it also means it's way, way heavier to run. For a CPU-only setup like ours, the sweet spot is a 7 billion parameter model, or as you'll see, it's 7B. It's plenty smart for real coding, but it's light enough that it won't make our computer cry. Next up is this thing called quantization, and you'll see these little Q numbers all over the place. Here's a great way to think about it. It's just like image compression. A Q8 model is like a perfect, high-quality PNG file. It's big and lossless. A Q4 model, on the other hand, is like a JPEG. It's smaller, way faster, and has a tiny drop in quality that you'll probably never even notice. For what we're doing, Q4_K_M is the absolute perfect balance between speed and performance. You're also going to see models labeled base and instruct. Now, base models are just trained to, well, continue text. It makes them really unpredictable. Instruct models, though, are specifically fine-tuned to follow your commands. So for a coding assistant, you always want an instruct model. No exceptions. And last but not least, the format. This one's super simple. If you're on Windows or a standard computer, you want the GGUF format. That's it. MLX is a special format just for Apple's own chips. So for us, that means we're grabbing the QN2 7B instruct model in that Q4_K_M GGUF format we talked about. Awesome, we have our model downloaded. Now, before we fire it up, we need to quickly tweak some server settings right inside LM Studio. This is super important to get the best performance out of our CPU without totally overwhelming it. All right, there are just three settings we really need to get right. First, the context window. This is basically the AI's short-term memory. If you set it too high, you'll just gobble up all your RAM. 4096 is a fantastic starting point. Second is temperature, which is just a fancy word for randomness. For coding, we want our output to be reliable and predictable, so we keep this number low. Somewhere between 0.2 and 0.4 is perfect. And finally, GPU offload. Well, since we don't have a GPU, we're just going to set that to 0. Easy enough?
With those settings all dialed in, we just head over to the Developer tab, select the model we downloaded, and click Load Model. As soon as that's loaded up, we just flip the server switch to running. And just like that, you have a live AI server running on your very own machine at localhost 1234. How cool is that? So our AI is up and running, which is great, but right now it's kind of trapped inside LM Studio. The next big step is to connect it to where we actually do our work, VS Code. And we're going to do that with that awesome free extension I mentioned earlier called Continue. Okay, let's get this connected. Pop open VS Code, head over to the Extensions panel, and just search for Continue. Go ahead and install it. You'll see a new little icon show up in your sidebar. Click that, tell it you want to add a new chat model, and then just pick LM Studio from the big list. And here's the best part. Because our server is already up and running, Continue literally finds it on its own. It's automatic. No messing around with config files or any of that nonsense. It just works. All right, the whole setup is complete. Time for the moment of truth. Let's give our brand new, totally local AI coding assistant a real-world job to do and see how it handles it. And we're not going to throw it a softball here. I'm giving it a proper chunky prompt. Write an Ansible playbook, which is basically an automation script, for network gear. And I want it to handle different operating systems and save a backup file using dynamic variables. Let's see what it comes up with. Now, while it's thinking, you can actually peek over at the LM Studio logs and get total transparency. You can literally see the requests come in from VS Code, you can see the server applying all our custom settings like the temperature and the context window, and you can watch as your CPU calculates the response token by token. This is a level of insight you just never get with those cloud-based AIs. And if you were to check your task manager during this whole thing, well, the proof is right there in the pudding. Your CPU is humming along, RAM is being used, but your network activity for both VS Code and LM Studio is flat at 0. Absolutely nothing is leaving your machine. It is 100% private and 100% offline. And there it is, a complete functional Ansible playbook. It's got the right syntax, it's got the platform checks, and it even includes helpful comments explaining what each part does. And all of this was created right here on this very machine, completely offline. So, just to wrap up with a few pro tips to make sure you get the best experience possible, definitely stick to those 7B models for speed. Keep that context window at 4096 unless you absolutely have to go bigger. Close other heavy apps to free up as much RAM as you can. And hey, if you can, store your models on an SSD. It makes loading them so much faster. So here's the thing. We just built a complete, seriously powerful, and totally private AI development environment. It's running on a standard machine, and it cost us absolutely nothing. The barrier to entry for this kind of technology? It's gone. It's in your hands now. So the only question left is, what are you going to build next?